Okay, before we solve this exercise, we have to master these concepts on the right. Finding the gradient, knowing 2 points, you know that you have a line, or you don't even have to have the graph or the line, but if they give you the coordinates of the points A and B, for instance, you identify x1, y1, x2, y2, you plug it into the equation of the gradient, which is y2 minus y1 over x2 minus x1, or rise over run, or the difference in y over the difference in the x-axis. So all of that is the gradient. You plug the numbers here and you get your value. Finding the equation of the line, knowing 1 point and the gradient. First, they give you the coordinates of 1 point, they give you the gradient. You plug everything you have into the equation of the line. Y equals mx plus b. So m is -2, you plug it there. -3, it goes -3 in x and then y. Remember, x and y? So you plug the -3 in x and you plug the 4 in the y. You solve this, so 4 equals -2 times -3, which is 6, plus b. You take the 3 to the other side, the 6, sorry, to the other side, the 6 becomes negative, so -6 plus 4 is -2. Or you subtract 6 on this side and you subtract 6 on the other side and you get -2. So -2 equals b, or b equals -2. I prefer to say it like this, but it depends on your choices, okay? And then how do you find the equation of that line? You only plug m and b. So you plug m, the green, there, and the b. What else? Gradients of parallel lines, they have to be the same. Examples, they don't have to look the same. 8 over 4 is the same as 2. So they don't have to look the same, but they have to be the same. Okay, and here, I don't know, 4 equals 4. So the gradients have to be the same of the lines. Okay, and well, actually, in this case, they would be negative. -8 over 4 and -2, because you have negative gradients there. Then, gradients of perpendicular lines. When you multiply them, the answer has to be -1. I know that's not what we saw before. I said, okay, let's say you have a number 3. Then the perpendicular, okay, that is let's say it's a -3, because the orange line is negative, right? It's going down. So it's -3. Your perpendicular line, the gradient, you have to switch the 3. This is 3 over 1. Even if we never see it, it's 3 over 1. You switch them and you change the sign. So it has to be positive. If you switch them, the 1 goes on top and the 3 goes in the bottom. The 1 goes on top and the 3 goes in the bottom, and they become negative, right? But what if we multiply them? This is how we prove it. If you multiply these times this, the answer has to be -1. Let's see, -3 times 1, -3, divided by 1 times 3, 3. 3 over 3 is 1, and we have different signs, so the answer has to be negative. And that's how we get to prove that we multiply the two gradients and we get a -1. Another thing we have to keep in mind is that if we have a right triangle, we have an angle which is 90 degrees. And if we have well, depending on the sides, we could have equilateral triangles with the 3 same sides, isosceles with 2 sides that are the same. These 2 lines, these thingies, mean that the sides are congruent, or the sides have the same length. And scalene, it means that you don't have any side that is the same. So this would be 1, 2, 3, for instance. None of them are the same. In this case, you have 2, 2, 2, 2, 2. Okay? I don't know if that made any sense, but I hope it did. Okay? Now, based on all of this, okay, one more thing is that if we have 2 lines that are intersecting like this one, that is the solution. That is the point of intersection. And that also means that on that point, the point becomes orange and purple at the same time. Orange and purple at the same time. So that means that if I have an equation of the orange line, y equals -mx plus b, I know because minus is because it's negative, the gradient of the orange line is negative, and let's say that we have the equation of the purple line, y equals mx plus b. At that point, there in the middle, the intersection between them, I can say that both equations are the same. What does that mean? Y, the orange y, equals the orange line equals the purple line. They share everything. They're partners. So they combine everything. So I can say that mx plus b, which is y, right? The purple y, equals minus mx plus b, the orange y. So in this case, once we have it like this, because y equals minus mx plus b, so the orange y equals minus mx plus b, the purple y equals mx plus b, the purple y equals mx plus b. Why do we say that they're equal? Because they're sharing the same point. Only when that happens, we can say that both equations are the same at that point, okay? This will allow us to find the value of x. Why the value of x? Because you have x here and here. And when you have x, and this m is a number and b is a number. A number means a constant. So you can have just one value of x. I'm going to show you what this means later, but I need you to know this. The point of intersection, you can say both equations are the same, and then you're going to be able to find values or of the variables that you have. Okay, this is also systems of equations. Okay, now let's go back to the exercise. First, they say find the gradient of line segments AC and BC. So AC, line segment AC, do we have information about this? Yeah, they give you the coordinates of A and the coordinate of C. And the gradient, how do we find the gradient? You have it here. So I'm going to do it fast, okay? Let's say this is for this, I'm going to say the green gradient. So the green gradient, how do we find it? Let's say that this is x1, y1, and this is x2, y2. So y2 is k minus y1, 0, over x2 is 0 minus x1 minus 3. And that equals what? Something minus 0 is the same something. And then 0 minus minus 3, multiplying signs that are the same. When we multiply the same color, the same signs, the answer is positive. So negative times negative, positive 3, or just k over 3. So this is my first gradient, k over 3. And then we have to find the gradient of the line segment BC. BC, this is the coordinate of B, so it's going to be x, let's call it x1, y1, but in red. And again, we have C, x2, y2. Okay, so this is going to be the gradient of the red line. The gradient of the red line goes like this, y2, k minus y1, 0, over x2, 0, minus x1, 3. So it's just k over minus 3, or minus k over 3, because it's going to give you the same answer in the end. So the gradient of the red line is minus k over 3. That's it. That's part A. If ACB, C has this house, this roof on top of it, right? So that's the angle, that's where the angle, whatever they say, we have to use it there on this letter because it has this cap here. It's a right angle. So we know that our right angle is going to be here at C, okay? If ACB is a right triangle, it's a right angle, use A to find the value of K. They say use A to find the value of K. What they say about that it's a right angle, the only thing we care about is if the lines are parallel or are perpendicular. And since they have a right angle, like this one, the lines are perpendicular, and this is what we have to keep in mind, okay? So they ask us to find the value of k. The value of k, actually we didn't need to know all of this right now that I figured it out. I'm sorry. Okay, So they're perpendicular. So what do we have to do with the gradients? Do we have the gradients? Yes, we have the green gradient and the red gradient. And we have to multiply them, and they have to be equal to -1. Okay, so let's do that, because they said if this angle here is a right angle. That's it. Use A means use the gradient, the red gradient and the green gradient to find the value of k. Let's use them. The green gradient is k over 3 and the red gradient is minus k over 3. Yeah, minus k over 3. K over minus 3 is the same thing. If you plug this in the calculator, they have different signs. Look, positive and negative, negative, and then this is positive and positive, but then you have a negative outside. Let's forget about this idea. Okay, or you have a negative and a positive. That means your whole fraction be negative because they have different signs. So here I'm choosing the k to be negative. You could choose the 3. It depends on you, okay? So you multiply them. How do we multiply them? Top by top and bottom times bottom. So top times top. Negative, positive times negative. Different signs. When we multiply them, we get negative. K times k. K squared is not 2k. It's not 2k. K plus k. Yes, this is 2k. But k times k is this. Look, you have a number 1 here and a number 1 here. 1 plus 1, 2. And that one was 1 house plus 1 house, 2 houses. In this case, you have house times house. So this one goes on top because we never see it and it's positive. What do we do when we have powers? We leave the same base and we add the exponents. So 1 plus 1 is 2. So it's k squared. It's not 2k. I wanted to make sure you know that, okay? Okay, and then in the denominator, or the number in the bottom, is just 3 times 3, which is 9, okay? That is going to be our value of the denominator here, 9. Okay, and okay, I mean, I wasn't supposed to do it like, I was just showing you that when you multiply these two, all of that has to be equal to -1, remember? -1. Why -1? Because when you multiply these two, the answer is -1. Let me take it back a little bit there, and let me show you. This equals -1. How do we solve this? Like this. And we equate all of that to -1. Now we can solve this. How do we get rid of the number 9 in the bottom? We multiply each side by 9, and we solve it. We can cancel the 9s. Why? You might be wondering, there's a negative between the 9 and the k. Yeah, but you're multiplying, you have brackets. If you have brackets, in the end, you can do this. 9 over 9, 1. So negative k squared equals -9. Then negative and negative, I can multiply everything times negative. This side by negative and this side by negative. Why? Because I want the k to be positive. And then it becomes positive, and then it affects whatever I have on the right side. In this case, it was a negative number, so it's going to turn positive. Okay, now I have to solve this. Okay, if you're still wondering about this 9 and this, you could do it step by step. And let me show you step by step, because I always have to do it. I'm sorry. So you have the 9 on top, minus k squared, and the 9 in the bottom, right? Why did I put only a fraction 9 there? Because I can say that this 9 is over 1. So 9 times -k and 1 times 9. So 9 times -k is -9k squared, because you keep the numbers and the signs and the letters, everything. And then 9, or 1 times 9 is just 9. What happens when you divide 9 over 9? You get a number 1. And you have a negative and a positive. Different signs, when you divide or multiply, are going to give you a negative answer. And that's how you get -k squared. Just in case, and just double checking with you. Okay, now we have to get rid of that square. What can we do to undo that square? If we have a square and we want to get rid of that, we take the square root. And if we take the square root, if we take the square root on one side, we take the square root on the other side. These two cancels with these two, and then we have k equals plus or minus 3, because 3 times 3 is 9. 3 times 3 is 9, but minus 3 times minus 3 is also 9. That's why we take the two signs, because either way is going to give you a positive 9. So what 3 are we going to keep, the positive or the negative? Because we only have to find one value of k. I'm going to show you, oh, I wasn't supposed to erase this, I'm sorry. But I wanted to show you that your k is here, right? So this is 0, x 0, you go up, you have to go up. So is your y here, your y, on the positive or the negative side? On the positive side, right? So k is up, so it cannot be negative, so you take the positive 3. Only because of the sketch. You look at the sketch and you say, okay, my lines are on top, above the x-axis. All the y's that I have are positive there. So I take the positive 3. How do you cancel the 2 and the square root? Yes, I know. Let's go back a little bit. I'm going to show you that. When you have the k square and you take the square root of that, you have a hidden 2 here. You have a number 2 that is hidden. You can rewrite this like this. I'm going to say that k is in red, so I'll leave the k. And then the green number, the green 2, you keep it with you. And then you're going to divide that by the 2 that you have outside, that you never see because the square roots are square for a reason. So you have always a number 2 there. You see? So this is what's happening there. So you keep the k, the base, and you have to divide. 2 divided by 2. You are dividing the two numbers that are the same. So the answer is 1. But you don't write that number 1, and that's how you get only k. That's how you get this k over here. That's how I can say, oh, I cancel this and this. This is what's actually happening. I get the power, the exponent, I divide it by the index, and I get a number 1. But if I do that on one side, if I take the square root on one side, I have to take the square root on the other side. What if it wasn't a number 9 or a square number that I could get on, that I could get an integer or a whole number as an answer? Well, you leave it as a third. You leave the third. Well, how's that? Now that I'm talking about it, I have to give you an example. Yes or yes. Look at this. K squared equals 23. Okay. Is there a number, a whole number, an integer that you can multiply twice by itself? By itself to get 23? Not really, right? So you say, okay, I take the square root on this side, the square root on the other side, and I get rid of this. So k equals plus or minus, and you leave it like this, the square root of 23. So you're leaving your answer as thirds. If you read this, if you ever read this, this is how you leave it. The thing is that we had a number 9, so plus or minus the square root of 9, and we know that the square root of 9 is 3, so plus or minus 3. And that was the difference. I hope this helps. I hope this is helping you, okay? But if not, let me know. Okay, so that's how we find the value of k. Where do I have it? Well, there. Let's see.